To begin our discussion on cryptography, it's helpful to discuss some of the basic components of encryption, and the two basic components that we want to look at first are algorithms and keys. Now, algorithms and keys are pretty much the two primary components of encryption, and in order to understand cryptography, you need to understand algorithms and keys themselves. Now, algorithms are basically the mathematical formulas and the methods that are used to determine how the entire encryption process takes place and how it's used on plain text to produce ciphertext. Now, the keys, on the other hand, are the variables that are combined with these algorithms to transform this plain text data into ciphertext. Let's talk about the algorithms a little bit more in depth. Now, algorithms, as I said, are complex mathematical formulas. And in general, they use very large numbers to produce encryption schemes, and which numbers they use really depends upon the algorithm itself. Now, algorithms are classified in several different ways. You can slice them and dice them a couple of different ways, in fact. First of all, they can be symmetric or asymmetric. They can also be hashing algorithms, and we're going to cover those three types of algorithms a little bit later. Algorithms can also be considered as streaming or block, and sometimes we hear the term streaming cipher or block cipher. But what that really boils down to is how it handles the data. Streaming means that it comes in streams, one character at a time, continuously, and the block means that it takes blocks of maybe 64 characters or bits at a time. Now, algorithms in general and their methods are typically publicly known and tested. And we do this to test for weaknesses because the algorithm itself should be well known and it should be put through these tests to determine if it's a good algorithm or not. A man called Kirchhoff, a long time ago, said that in encryption, the algorithm should be the known part. The key, on the other hand, should be the confidential part. Anyone can use any algorithm to encrypt and decrypt with. It's the key that's secret. Now, unknown algorithms, such as some of those that may be used by the government, for example, Skipjack comes to mind, which was an early algorithm several years ago that was tested, but it was kept secret for a long time, and it's not really generally known very well, so it may have had weaknesses that could not be tested publicly. Now, several different types of algorithms exist based upon different mathematical properties, equations, or theories. Typically, we may see those in encryption in terms of large prime numbers, for example, and the difficulty in factoring them. Also, elliptic curves is one method that may be used in an algorithm to produce encryption. So there are different methods that are out there, and you're not expected to know all of these for the exam. What you're expected to know are more the practical how to use these algorithms in terms of encryption. Now, let's talk about the key part. Whereas I said the algorithm is typically the known part. Anyone can use any algorithm because it's been known, it's public, and it's tested. Keys, on the other hand, are the variable process of this, the variable part of this entire process. Keys are called cryptovariables, or sometimes just simply variables, and they're the portion of the process that really is considered confidential or protected from disclosure. No one knows what these keys are, and they shouldn't. You can keep these keys private for yourself. And in fact, in another scheme called asymmetric encryption, there is a public key and a private key, and we'll talk about that a little bit later. Keys in general can be simple or complex. Now, in earlier forms of cryptography, like substitution cryptography, for example, the key might have been something very simple, like a letter or a word. In modern cryptography, however, keys are typically very complex. Large numbers, in fact, large hexadecimal strings of numbers could be the key. Or you could have a very long password that's hashed or encrypted, and that encrypted hash or encrypted result becomes the key. In any case, they're typically very long and complex numbers. And in general, the stronger the key, the stronger the encryption. The stronger the algorithm, the stronger the encryption. That's just two generalities about encryption you should know. Now, keys are typically defined by the entity that wants the encryption or in the first place, or owns the data. And they may go through a third party to get keys generated, or they may generate their own keys. But in any case, these keys are not generally out there in the public, except in the case of public and private key cryptography. There are a large, wide variety of methods that are out there, some of them very complex, that are used to generate keys to be used in encryption schemes. Some of these you can do on your own computer. Some of these require some significant computing power. And as we go through the course, we'll look at examples of algorithms and keys, and you'll see how the stronger the key, the stronger the encryption method. The stronger the algorithm, the stronger the encryption method. And obviously, strong encryption means that your data is more secure. So how does this process work? Well, in general, you take plain text data and you feed it into an algorithm. And the key, the variable part, is inserted into the algorithm as well, because there may be places in the algorithm where you need to feed the key in to make changes to the data. Once that process takes place, the result is the encrypted data, or ciphertext as it's sometimes called. Now, obviously, this is a very simplistic view of the encryption process. It's actually very complex. But for our purposes, this is how it works. And again, you don't really need to know the mechanics of it. You do need to know the application of it. And in order to know the application, you do need to know the basics. And that's what we're covering during this part of the course. So that's keys and algorithms. And in the next few sessions, we'll talk about how these keys and algorithms are used in the different types of cryptography.